something. So Proofgold is a cryptocurrency or blockchain supporting formal logic, formal proof, and formal math. It's built mostly on a project called Caritas, which I will say something about later. I will explain maybe to some extent these concepts like proof of stake and proof of burn. But the point is that it sort of isn't some sort of heavy Bitcoin proof of work energy mining, but it's sort of an interesting combination of two ways how to secure a blockchain. And it's also interesting because it's relying on another established blockchain called Litecoin, which is like the younger brother of Bitcoin. It allows what you would expect from a blockchain for formal maths, like publishing theories, definitions, conjectures, and proofs. It also, like I guess the main selling or interesting point includes a bounty and ownership system for, like, you can put a reward on somebody else proving the conjecture for you, and there are some mechanisms for the person who really proves the conjecture for his money not to be stolen or redistributed by some central committee, right? So that's the main point of blockchains in general. The sort of blockchain network is the law, right? Like there is no central bank which will take away your credit card payment or whatever, right? Like that's the dream of the blockchain people.
Quick question.
Yeah.
Is that one of those things that we don't know who is, this creditus code base is one of those things that we don't know who is doing it? Or?
I will say it in the next slide.
Thank you.
It's quite a bit based on Chad Brown's favorite attempts at proof assistance called Egal and later Megalodon, which is some sort of higher order logic. But today you can also interact with it using hopeful and version proof, like two interactive, one interactive and one automated theorem proving. Initially it was announced in June 2020 by this memo.cache thingy, which is some sort of super secret way how the blockchain people communicate without revealing their identities. So I think the point the announcer calls himself Blake Kyler, nobody knows who it is, so it's sort of modeled after this Satoshi Nakamoto thing announcing the Bitcoin blockchain in 2008. And like I guess the reason why people are doing it this way is that it's sort of classical way of let's announce a blockchain from scratch so that everybody has a fair chance of getting into it, like without, I don't know, me immediately grabbing 20% of the whole money supply to quote-unquote support the blockchain development or whatever. And also people do it this way because they don't want to be exposed to some, I don't know, SEC people suing them in the United States, etc. So it seems to be one way how people are starting blockchains these days. There is an explorer that I will show you later. There are today 3 to 4 different clients. So the one that is like most developed and most used is this Proofgold Lava client, which I will say something about later. The original one is this Proofgold Core, which was basically published when the announcement was made. And there is another one which is more lightweight, this Proofgold Lite, which allows some sort of less resource, like heavy running. There is also one which I couldn't quickly find, which had some extra features, like, for example, atomic swaps between Proofgold and Bitcoin. So I can explain later which are atomic swaps. We wrote a paper for this FMBC, formal methods for blockchains or something like that, in 2022, when basically mostly Cesare developed the Lava client. So he gave a talk in Haifa in 2022. And later Cesare got this ERC proof of concept project, sorry for the typos, which like finances the development and quote-unquote commercialization of some of these parts. So these ERC proof of concept projects are directed at some sort of commercialization of the research in the European Union. So this is the history. So you probably all know that there is this Bitcoin thing, which was announced by this magical Satoshi Nakamoto in 2008 in a white paper and launched in early 2009. And we can spend years discussing blockchains, I guess, right? So maybe let's not do it here. In 2011, somebody sort of cloned the Bitcoin blockchain and did some changes which sort of made it faster. It's also cheaper and smaller for various reasons. So Chad Brown was probably an early blockchain / Bitcoin like aficionado or whatever you would call him. So in 2014 he came up with this Mathgate website where he had the idea that you would sort of put some amount of Bitcoins on particular proofs, like so this Mathgate was sort of an educational website, and you would have always like a competition where people would need to register by paying some amount of Bitcoins, and then they would be competing in solving like educational exercises. And if you got exactly the proof that he intended, written typically in his egal system, if I remember correctly, then the proof would hash to the private address or to the secret that you need to basically get the bounty connected to this particular exercise. So in some sense, it was, I think, like the first idea to apply this sort of distributed blockchain technology to formal math. Like the obvious disadvantage of this, like yes, it has this distributed, decentralized property that whoever gets the right proof can claim the bounty. But the obvious disadvantage is that you need to get exactly the correct proof. Like you need to get exactly the proof that Chad intended, so that it hashes to the right or whatever secret for collecting the Bitcoin. So like I think he didn't achieve much with this project. So then there is this company called IOHK, which is related to these rich CMU people. Again, this is a lot of history. There is a very funny book called Cryptopians, which sort of recounts the history of Ethereum. And basically, IOHK is a product of Charles Hoskinson, who was one of the Ethereum founders, who at some point sort of parted ways with the Ethereum people and started his own company, Input Output Hong Kong, where they were developing another blockchain called Cardano, which became big, so that all made them rich. But in 2016, they were also developing this Creditas, which was supposed to be a blockchain for a formal proof, basically. So I don't know much about it, but what seems to be the case. And again, I haven't done too much sort of historical digging to compare the code bases. Is that basically Caritas was never launched. I don't know what happened then at that point, like why it never launched, etc. But like the code was put out there publicly. Somebody forked it in 2017, creating something called Dalil coin. And I don't even know whether it ever ran. And then basically based on this Caritas and Dalil coin, the Proofgold code emerged, which really started to run in 2020. In between, there were different other ideas, like for example, this math coin in 2018, which is also like an interesting reading about like the world of blockchains and mathematics. Then basically Cezary Kališík got involved in like 2021 and 2022, starting to work on the Slava client, and then the slide client appeared. Then Cezary started to work on the Proofgold Explorer in late 23 and in 24. And this year, there's a Megalodon wiki which is linked to the Proofgold Explorer emerged. So somehow these two things are now somehow connected. So you can sort of put some formalization done in Megalodon into the wiki, and that sort of, for example, creates the Proofgold documents that go into the blockchain. And from the Explorer, you can sort of link back to the Megalodon wiki, etc. I will show you some examples. So a bit about this wiki. It's a like I think calling it a wiki, like today you might call it just some sort of GitHub page with HTMLization. I may maybe quickly skip forward to an example. So you, this is probably too small to see, but it shows like one proof, like one theorem, and it's proved written in the Megalodon system and HTMLized. So some of these things would be clickable, like for example up there are the links to the Proofgold Explorer, and it sort of shows you occasionally with some hyperlinks to the symbols, etc. So that's the point of these like formal math wikis, that you have some sort of automated verification and HTMLization, and in this case also like the connection to the blockchain. So basically it's some sort of GitHub repo these days, which people can clone, fork, edit, etc. It's guarded by some sort of GitHub action that sort of runs the verification and HTMLization, and if that fails, then the GitHub will not accept it, etc. And I guess you can maybe you can also try to look at it in a browser if that thing will work. So let's see, B. So which one was I looking at? Part 12. So let's try to go there. And yeah, maybe this is more readable than the way I was showing before. So I don't know. This seems to be simple enough that even I understand it. So this probably defines the set of real numbers. Is it true? These are the complex elements of the complex number set. So the real part of Z equals Z. So it's not a definition, it's actually a theorem. And the theorem has a proof. And let's see if we can click on this thing. Yeah. So now we sort of got ourselves from the Megalodon wiki to the Proofgold blockchain explorer. So you can see that like these statements also live in the explorer. You have all sorts of information about this statement, like what is its proof, in which theory was it proved, what is its type, what is its name. Then you have like its Proofgold address and some sort of metadata, like who created, who owns it, I don't know what this term. So these things are the things that the blockchain shout at me.
This, yeah. Fine. The theorem's fine. Why is the proof language so unbelievably verbose? Like, the first proof is a one-liner and a decent proof assistant. Like you pattern match, and then like.
So we can get into flame wars about proof languages here, but like this is Chad's thing, so if you for example look at the MetaMath proof explorer, you will get probably similar verbosity. I'm not sure. So this is not an isolated event, but yeah, well that's like whatever. I will not engage like. We used to have this flame war mail list in Nijmegen, and like yeah, there is other things in this formal proof world, but yeah. If you want another proof format, complain to chat.
There might have been a reason. Right? Sometimes there are motivations for like Isabel is also wildly verbose, but it's not an accident, right? It's by design for a whole bunch of purposes. So sure.
I mean, this is doing a natural language reproduction of the. This is not the actual proof term. This is trying to explain the proof term to you, right? And so it's doing, and it only has the core proof term, but it's reconstructing, like rewrite the current goal, blah blah blah.
Okay,
right?
because the proof term is like trivial. Then the previous one is just.
Yeah, I mean. But I mean, well, trivial still means, well, you have to introduce your variables and then observe that it's reflexive.
Like, if you have pattern matching, it's like, you know, the first fourth.
Yeah, this language doesn't have pattern matching. This language is like higher order logic, right?
Yeah.
So the higher order logic, you know, it's not a built-in. Right?
I'm trying to get the proof in the Proofgold language, which is actually more verbose to make you even happier. Oh no, this is not the right one. No. I cannot.
I mean, fancy proof languages have complicated implementations. You don't necessarily want to put complicated implementations on a blockchain, right?
Yeah,
I will.
Yeah, sure. And that's why I'm asking, right?
Yeah.
What's the motivation here?
Yeah, well, I don't know if I have the slide, but so maybe let's switch to the slides here. Oh yeah, these are some screenshots that I have now shown you live. I just put them into, but like not to forget your point or Mario's point. The thing I'm not sure if I have it in the slides is that for these applications you want to avoid some sort of blow-ups, right? Like somebody may try to attack the blockchain by various means, and so you could have like a very compact, powerful proof language in which you write something like an Ackermann or and then what do you do, right? Like then, like in here there are like two kinds of limits. There are limits on the size of block, like the proof in the particular instantiation of Proofgold cannot be bigger than 0.5 megabyte, like in that particular format. And on top of that, there are some sort of resource limits inside the proof checker, which is sort of part of the client of the software, which will hopefully prevent some sort of Ackermann. Well, if it simply runs out of the resource limits, then the client should refuse to sort of put it into the blockchain, or it's not illegal. So yes, there are these things, and I guess it's not trivial to do them, because if really somebody hates you, then they will try to exploit some weakness like this in the blockchain, and then you may have to do something like do a hard fork. But I don't know, like for example, the Bitcoin people really hate doing hard forks, right? Like the Ethereum people don't hate doing hard forks, but because we've got some other people hate the Ethereum people. So this is a very complicated world. Yeah, so this is a bunch of screenshots, which is probably better to show you. I just put them into the slides in case the demo fails. What is interesting is that it's being used for all these bounties. So let me try to go to this Explorer main page. So this sort of pie chart tells you that there is like 300,000 worth of Proofgold on some open bounties coming from, I don't know, the abelian inner mappings project, the serial number formalization, the OBIS programs, the MISA programs, etc. It's like a pie chart. I will show you a slide about it later. You can click on this, and you can see the sort of most valuable open and most valuable collected bounties. So, for example, I know maybe I advertised it here. Thibault Gauthier has recently proved Ramsey 4.5 equals 25, which is like a huge 1 petabyte proof. He proved it formally, but it's currently no chance to put it into this blockchain. But there, apparently somebody in Thibault claims it wasn't him already. Already collected the bounties for these easier Ramsey-style problems. And if you prove FLT, then you will get 5,000. So do it on a small page like Fermat, etc. So Ramsey 4.5.25 is still there. There's always some category theory, etc.
So even if Kevin succeeds, I don't think he's going to collect.
Well, it depends on the prices, right?
What does these numbers mean?
Like that's the 750.
Yeah.
That's the money.
Yeah, but in what units, right?
Like $5?
How much should we?
Go right, like.
What's the running?
Bitcoin?
I'm just curious because I never have imagined that we have, as mathematicians, a problem of distributing money for proofs, except for a few questions that have large sums of money attached to them. So I mean, it's a cool little project, but what problem this is solving, I don't see.
Okay.
It's not a little, sorry. It's a cool and big project. I just don't see what problem it is solving.
Yeah, we can probably discuss it during the coffee break. So anyway, the current amount of open bounties is like 300,000. The collected bounties is like 2.
Yeah, but if like one of those is worth €1 micro, then
So I like okay, you probably want to start some discussions about blockchains here. I didn't want to spend too much time on this. Like you probably all know that the prices of blockchains are notoriously crazy, and like when Chad started Mathgate, he put 14 bitcoins on his small educational exercises, which anybody who would care could have collected in one day, basically, right? So how much is 14 Bitcoin today? If I had them, I would be quite rich, right? So like these things have some weird dynamics. I'm not an expert. Some people like it, some people do it for some sort of, I don't know, crypto-anarchistic ideals, like Chad is probably one of these guys. Some people do it because they want to get rich. Some people pump it and dump it in some Ponzi schemes. So it's like there are interesting books written about this whole blockchain landscape.
Is it maybe, sorry, I know you don't want to sit on this point so much, but for example, there's the system in internet forums like Overflow, which is some point system. Is it akin to that more? And you know, the people who has the more points have more street cred kind of thing.
Yeah, you do have karma points. I don't deny. Yeah, there are various things.
Relative to the H index.
Oh yeah. What would I also wanted to maybe show? Let's see if I can do it. Oh yeah. So the overall circulation, so all these blockchains work by producing blocks in time interval. So I think Proofgold currently produces like roughly 1 block per hour, which is not too much. It's been running for 4 years, and I think initially there was like 50 Proofgold created during each block, like that's typically called the block reward in the blockchains. And I think today it's only like 25. And because of these things, the overall circulation is today like 1 million Proofgold. And I think the total limit, like typically these things somehow stabilize in this world. What I believe is the maximum thing after it's been running for 1 million years. So what will be something like 11 million Proofgold. So today there's like 10% of it sort of printed. This is the overall number of transactions throughout the 4 years. These are addresses that at some point held or still hold some throughput. So that's this. Yeah, so there are these theories, which again I'm not a big expert on, but I can probably click on them here. So I think the main one, like the beginning, it's some sort of intuitionistic high-order logic with these two simple types, O and I, and implication and universal quantifier. And you have these proof terms for Kari Howard. Then there is this HF theory which is built in of hereditarily finite sets. Then finally there are 2 axiomatizations of Higher-Tarski-Grothendieck. There is this higher-order abstract syntax, where the default syntax is binding, so I think it's more program stuff. And maybe there were some more, and I think the point is that you can create a new theory and start your development in it. Can I switch to this? Yeah, that seems to be it. Yeah, so the bounty system is, again, I'm not an expert, but the idea is that you can basically at any time create a proposition conjecture, and also at any time you can attach a bounty or an additional bounty to that conjecture. Initially, there was this idea, because many people, I guess, in the beginning of Bitcoin, were annoyed by this idea of proof of work, like people are solving boring hashing contests or whatever. So I guess many people a decade ago were thinking, like, why don't we come up with something useful like theorem proving, right? Like instead of the stupid mining using hash functions, why don't we use this huge power which is used for mining Bitcoin for theorem proving, for example. So to some extent, I think Proofgold initially tried something like that. So they, in each block, they randomly chose one of, I don't know, maybe 5 or 6 classes of problems. And they would put a bounty on the problem, and that typically means that you get the bounty if you prove the problem or if you prove the negation of the problem. So the fact that these things were randomly generated weren't so bad in the sense that you would be like throwing away, like completely burning the money, because if you are generating an unprovable conjecture, then you can prove the negation, etc. Still, it was probably a bit strange in the sense that it's hard to sort of fine-tune randomly created conjectures for having the right kind of difficulty. Like in the standard Bitcoin mining, the fine-tuning process, like the difficulty increasing process, is sort of reasonable modulo some obviously new hardware, etc. But still, it seems to be quite resistant. Whereas here, I don't think there was any fine-tuning process to it. But to some extent, it was like the idea of you will get some quote-unquote mining reward if you solve these theorems, right? Like in some sort of delayed way. So in some sense, it was a bit of a attempted solution to this Bitcoin mining problem, but I would say a failed solution. I guess the main motivation was to sort of get people into it initially, distribute the money reasonably about people who can prove theorems, and then this community would be sort of seeded with the Proofgold and put the Proofgold on interesting formalization projects. So this is an overview that you already saw in the pie chart. So there are these Ramsey graphs, for example. There is quite a few of them. At some point, some hard missile problems coming basically from my ERC project were added, like the problems that we really tried to prove and couldn't prove using automated theorem provers. To some extent appeared in the blockchain. At some point, we started this project automatically generating explanations for OEIs sequences, and we generated benchmarks for the theorem provers to prove or disprove equivalence between 2 programs that explain a particular sequence. And these problems are quite hard because they typically require induction or sort of multiple inductions. And today's inductive theorem proving isn't very strong. So again, like if you come up with a better inductive theorem prover, you can collect some Proofgold. Chad Brown was formalizing serial numbers, so there is quite a few conjectures based on his formalization. There is some category theory, there's Popperov's abelian inner mathematics, some randomly, I think these are sort of in the realm of the originally generated, randomly generated bounties, like during the block creation. So some of them were randomly created, quantified Boolean formulas. Some of them were about some sort of set constraints, which I don't know exactly what it was, high order unification, etc., etc. Like the last one was really like some general random generation of propositions. Well, then the initial code base wasn't very stable for, I guess, all sorts of reasons. So that's why in 2021, Cesare got into developing this Lava client. And I guess what really helped to make it stable is that it started to use like sensible database, databases for the various blockchain information. It switched to much better cryptographic like libraries. Like at some point I visited John Harrison and he was paid by Amazon to work on verifying different elliptic curves. So we took one of his verified elliptic curves, but you can also use the Bitcoin implementation, etc. So these things help quite a bit and replace the original sort of native OCaml implementation. And yeah, the new client is now really stable, and the old one was really horrible to run, like it was crashing all the time. The new one is now, I think it's been running for a year on some nodes. And Cesare also, as part of this ERC proof of concept project, started to develop this blockchain that I was showing you.
Out of curiosity, what language is it written in now?
It's still OCaml. Like this stuff like the GDBM and elliptic curves, etc. Like it's written in C, right? Or I think what John is verifying is even some machine or assembly code, but most of it is still OCaml. Then I don't know much about this. This is Thibault's work. So Thibault works with Hausdorff. So he started to basically import the Proofgold theories and bounties or conjectures into Hausdorff, creating some translations back and forth. And I think he sort of mostly succeeded in that. And he is sort of using all sorts of automated systems that he created for like Holy Hammer and Tactic-Toe, but also like built-in automation like Mattis to sort of prove some of these bounties. And then obviously he somehow needs to export them. And once he exports them, you quite often, because of the way these tactics work in Hausdorff, get a huge low-level proof. So for that, to sort of minimize these huge proofs, he actually wrote some custom internal resolution prover that sort of very carefully tries to squeeze the proof to this allowed size of one megabyte after when he's exporting Proofgold. Yeah, I guess I just said this. Yeah, so as I already said, like the sort of dream is that at some point somebody creates some really big project, like something maybe like Patrick was showing with this blueprint thing. And I guess this whole thing was to some extent motivated by Tom Hales doing FlySpec by assigning bounties on, I think he even has the bounties in the blueprint book, but I'm not totally sure. Like basically you write, you have a big project like formal proof of the Kepler conjecture, and somebody starts saying, okay, this lemma is worth 50 and this lemma is worth 100. And now the The disadvantage of doing that centrally is that somebody needs to distribute the bounty, somebody needs to say whether this is a proof or whether it's not a proof, whether somebody cheated or not. If you, at least the sort of selling point for the blockchains is that these things are decentralized and distributed. So if you have a project like this, you can be some anonymous person in India, and if you created a proof, you can collect the bounty, and you don't need to go through some hierarchy of people who would pay you, right? So I guess the main motivating idea is that blockchains like these could support distributed, decentralized, anonymous formalization. That's sort of the dream. Yeah, so I know how much I know about these things like proof of stake and proof of burn. So what I know is that somehow the Litecoin network is being used to secure the Proofgold network. So whenever a block in Proofgold is created, information about it, some sort of hash, is also written into the Litecoin network, which is quite fast and quite cheap, so that doesn't cost money. And I think the idea is that there are various attacks, especially if you only have a blockchain, I think the number of nodes running the blockchain is sort of today 20 to 40 nodes, which is not too much. So if you have somebody crazy, they might sort of do some hostile overtake of, if you have more than 50% in Bitcoin, you can steal all the money, right? So you don't want that. So I guess the proof of burn, using the Litecoin network, is some sort of additional security feature, which is saying, from now on, you cannot mess with the history. You sort of cannot rewrite the history. At least that's my very naive understanding, but I'm not an expert on this. What is also a funny feature is that you own the propositions that you proved, and there is a system of using these ownerships. So, for example, you can make other people pay for using your theorem sort of functions in other people's proofs. And there is this joke which I probably told you already, but maybe not to all of you. So Chad really hates Kuratowski pairs because he believes that there are better ways how to create all the pairs in set theories. So he created not just the definition of Kuratowski pair, but also all sorts of variations on that idea. So he owns them all in one of these theories. And not only that you would have to pay him, but he actually doesn't allow you to use these definitions. so you can do such weird stuff in using these ownership features. And obviously, I think you can sell the ownership, etc. Also, one interesting issue is that it's quite non-trivial to publish a proof, because imagine I know proof Fermat, I want to claim my 5,000 Proofgold, right? So fine, I create the Proofgold document and I throw it into the blockchain. Now, okay, I send it to a bunch of nodes and they say, no, this guy didn't prove Fermat. I have proved Fermat. so you have this problem of stealing the proofs, right? So for that, there is this commitment system where before, once you have proved something, you don't immediately publish it unless you are stupid. But I think the system doesn't even allow it. So you have to somehow first create a hash of the document that you want to publish. And you first sort of pre-commit to this hash. You are sort of advertising, hey, I have a hash of a proof, and I will publish this proof later. And then, like this message is distributed throughout the blockchain. Nobody knows what actually happened, so they will put it into the blocks. And once it's like reasonably secured by the blockchain, you can publish the actual proof that corresponds to this hash. So in that way, it's sort of a delayed scheme which prevents others from stealing your money. Oh yeah, so there is this block size limit, which I don't know what to think about it. The current blockchain after these 4 years isn't too big, which is probably good. I think it's like 2 to 3 gigabytes. And of course, like you do have blockchains which are like a terabyte or whatever, but then you need crazy people with crazy hardware, right? So, and also, like I said, like Thibault now has proof of Ramsey for 5 equals 25, which is like 2 petabytes. So do you want 2 petabytes of proof to live in a blockchain, like distributed on 100,000 nodes around the world? Yeah, so these are like interesting questions when you are doing these things. Like the practical solution is this limit which forces you to split bigger proofs into lemmas. And like there is this issue of like trying to prevent some sort of poisonous proofs, some sort of attacks on the computation that goes on in the nodes by putting some sort of gas basically into the proof checking. And yeah, there is this isolation of theories to contain potential inconsistencies. So yeah, if you find a contradiction in Tarski-Grothendieck, you can claim FEMA, right? I think if you find a contradiction in Tarski-Grothendieck, you should be famous, so maybe. But yeah. Yeah, so this is sort of the end, I guess. So it's a reasonably active network these days. Like people are putting all sorts of bounties, proofs, theories into it. People are working on better clients and explorers and even interfaces to proof assistants. And I guess like none of this is like crazy developed at this point. I think if Cesare didn't get into it, then it would be like a really almost non-working project because Cesare is a very competent hacker. It sort of became pretty usable and is becoming quite interesting, especially like this connection between the explorer and the wiki, etc. Like obviously, like there is a lot of questions. Like would you like to create connections to other proof assistants? Would you like to create particular theories? Like I don't know, maybe didactic could be a good candidate because it sort of provides for Marius MM0, right? Like you could sort of think about some sort of other bottom layers for doing large-scale distributed proofs, and then can you actually do it in the system, or do you need to create like a slight variation of that system, and how do you deal with all these things, etc. Yeah. So yeah, I think that the main challenge is like how to make it usable, like whether it actually can be made usable in the current instantiation. Like there are people who use it. Like what Chad always says is that he thinks that the intersection between the blockchain community and the formal proof community isn't very big. So it's like a niche thing. But like some people believe in it, right? Like for example, Chad. So it's sort of I don't know like how this will develop. Like it could die, it could go crazy, it could sort of remain where it is. Like I guess we will see also depending how much people will invest into it and play with it and actually use it. Right? Like so this is the web page of this Cesar's commercialization project. So there was the question, how much is it worth? Like if you, I don't know, today have like 1 million Proofgold and the total supply will be like 11 million. How much is one Proofgold worth? And I think, so the way how to get Proofgold, like you cannot buy it at some exchange, that might be some future, but you can do a thing called atomic swap, typically for Litecoin, because it has this close relationship to Litecoin quite easily. So there are some historical data about prices, and at some point it was like, I don't know, maybe like $6 for one Proofgold. So if you prove Fermat, you would get $30,000. But I think the price recently dropped below $1 for one Proofgold. So I think it's a bit of a very immature market in the sense that the price can really fluctuate and the market isn't really deep, right? So like I said, you see all these effects that happen in the cryptocurrency world, like these pumpings and dumpings, etc. Right? So in the sense, occasionally there is some value to it. Like if you said, okay, the total supply is 11 million and it can climb up to 6 million, then maybe the value is somewhere around 50 million. But well, maybe also not, right? Like maybe the value is sort of zero, or it's just fun, or for some people like chat. Okay, so that's it. Thank you.